This is part 3 of the lecture on adjusted odds ratio. In this section, we will study 3 very simple examples of logistic regression analysis, models with no independent variable, only one independent variable, and 2 independent variables. For each case, we compare the logistic regression results with a corresponding contingency table. The data are drawn from NHANES. The dependent variable is self-reported general health, and independent variables are race/ethnicity and education. In order to make simple examples, the analysis is limited to only 2 race/ethnicity categories, Hispanic and non-Hispanic white. This exercise with very simple examples helps us to understand the logic of logistic regression. The simplest case is no independent variable. The first 2 equations show the general form of logistic regression, and in this case, there is no x, so only alpha, the constant, remains. Can we still do logistic regression with no independent variable? Yes, in this case, the logistic regression analysis estimates just the value of alpha, as seen in the table of logistic regression results, which is the upper one of the 2 tables in this slide. In this case, alpha was -1.4, and e to the -1.4 is 0.247. So the log of odds was -1.4, and the odds were 0.247. As shown in this frequency table, which is the lower one of the 2 tables, 0.247 is odds of being self-reportedly unhealthy in the data. W plus H in the frequency table means non-Hispanic whites and Hispanics. Among the 2,427 persons, 480 of them said that their general health condition was poor or fair, and 1947 persons chose good, very good, or excellent. The odds of being unhealthy was 480 over 1947, which is 0.247, so that alpha in the logistic regression model becomes log of 0.247, which is -1.4. The second simple example is a model with only one independent variable, which was a binary variable, indicating whether the person is Hispanic or not. Results of the logistic regression are shown in the upper table. Beta for Hispanic was 1.120 and alpha, the constant, was -1.813. The lower table, which is a 2-way contingency table of self-reported general health by race/ethnicity, shows how those numbers were obtained. Among the 723 Hispanic persons, 241 persons were self-reportedly unhealthy and 482 were healthy. The odds were 241 to 482, exactly 0.5. For whites, 239 were unhealthy and 1,465 were healthy. The odds were 239 to 1,465, which is 0.163. The odds ratio between Hispanics and non-Hispanic whites were 0.5 over 0.163, which was 3.065. How did these numbers in the contingency table determine the parameters alpha and beta 1 in this logistic regression model? For each group, the odds were given by the equation at the upper left corner. For whites, the odds were 0.163. For whites, x1 equals 0, thus the model becomes just e to the alpha. Alpha is equal to log 0.163, which is -1.813. Now, for Hispanics, the odds were 0.500. In this case, x1 equals 1, so we have e to the alpha times e to the beta 1. We already know e to the alpha, which was 0.163. So e to the beta 1 must be 0.5 divided by 0.163, which is 3.065. Note that this is the odds ratio between Hispanics and non-Hispanic whites. Finally, beta 1 is log of 3.065, which is 1.120. This example helps us to understand how relationships between variables determine values of parameters of the corresponding logistic equation model. Now, the last example has 2 independent variables, race/ethnicity and education. You may say, hey, there are 3 x's. Yes, because education has 2 binary variables, no high school and high school. This table shows results of the logistic regression. Education is also strongly related to self-reported health. E to the beta for no high school was 9.496. Because the reference category was graduated from college, this means that odds of being self-reportedly unhealthy for those who had not graduated from high school were about 9.5 times that for college graduates, controlling for race/ethnicity. Similarly, odds of being self-reportedly unhealthy, for those who graduated from high school but not from college, were about 3.5 times that for college graduates. And this number, 1.683, is the estimated odds ratio of being self-reportedly unhealthy between Hispanics and non-Hispanic whites, adjusted for education. But in the previous example, the unadjusted odds ratio between Hispanics and non-Hispanic whites was 3.065. So, although the odds ratio of 1.683, adjusted for education, was still quite high, it was much lower than the unadjusted odds ratio. Why? This table shows why. This table is a three-way contingency table, as it has three variables: education, race/ethnicity, and self-reported health. The top row shows column labels. Let's look at the next row, which shows the numbers of self-reportedly unhealthy and healthy persons in the total population. We saw those numbers in the previous slide showing the example of no independent variable. The following two rows show the numbers for Hispanics and non-Hispanic whites, which we have seen in the previous slide showing the example of just one independent variable. The bottom six rows show the numbers by race/ethnicity and by education. The odds ratio between Hispanics and non-Hispanic whites is 3.065 for the total population. The odds ratio is shown for each of the education categories as well. It was 2.3774 for those who have not graduated from high school, 1.153 for those who graduated from high school, and 1.974 for college graduates. Recall that the preceding slide has shown that the Hispanic versus white odds ratio, adjusted for education from the logistic regression, was 1.683. And each of those odds ratios, 2.377, 1.153, and 1.974, are also adjusted for education, and 1.683 may be considered as an average, though not exactly the arithmetic mean, of these three numbers. Note that all these three education-specific odds ratios, 2.377, 1.153, and 1.974, are smaller than the total odds ratio of 3.065. It means that the association between race/ethnicity and self-reported health becomes weaker if we control it for their relations to education. As indicated in the regression results in the preceding slide, education is strongly related to self-reported health, and education is strongly related to race/ethnicity as well, as shown in this table. In this dataset, 30% of non-Hispanic whites and 6.5% of Hispanics were college graduates, 56.4% of Hispanics and 14.3% of non-Hispanic whites had not graduated from high school. So, in this dataset, the distribution among education categories differed considerably between Hispanics and non-Hispanic whites. This figure was prepared for explaining the difference between the unadjusted and adjusted odds ratios. Race/ethnicity, which is just Hispanics versus non-Hispanic whites in this subset of data, seems to affect self-reported health. The direction of effect should be from race/ethnicity to self-reported health, not the other way, because health does not determine the race/ethnicity of the person. Probably race/ethnicity is associated with several factors that affect health more directly. This black arrow includes a number of pathways, which are put together in this arrow. The odds ratio from the bivariate analysis, which was 3.065, corresponds to the black arrow. Then, by including education in the logistic regression model, the black arrow was separated into two pathways: the pink pathway, which goes through education, and the gray pathway, which is more direct, in that it does not go through education. Because both of the pathways represent associations in the same direction, the association between race/ethnicity and self-reported health, corresponding to the gray arrow, is weaker than that corresponding to the black arrow, as reflected in the different values of odds ratio, 1.683 versus 3.065. I just said, both pathways, pink and gray, represent associations in the same direction. A few words may be needed to explain what it means. The gray pathway represents, for each of the education category, non-Hispanic whites had a higher proportion of people who were self-reportedly healthy. The pink pathway represents, non-Hispanic whites had a greater proportion of people who were in higher education categories, and higher education categories had a greater proportion of people who were self-reportedly healthy. So, each of the gray and pink pathways represents the tendency for non-Hispanic whites to have a higher proportion of people who were self-reportedly healthy. Okay. This concludes our study of the three simple examples on relations between logistic regression results and frequency distribution results.